Stellar magnitudes. Over 3 billion stars can be seen from ground-based telescopes. Only about 6,000, though, are visible with the naked eye. If you get above the atmosphere and you start talking about Earth-orbiting satellites that don't have clouds and weather in their way, you can see over 1 trillion stars are observed, with such things as the Hubble Space Telescope, the Kepler Telescope, and the James Webb Telescope. Here we have our famous Hubble Deep Field image, where over 10,000 galaxies were cataloged in one image over a 10-day exposure. We've talked about this in the past. Astronomers are going to talk about two scales when they talk about the brightness of a star. The first is apparent magnitude, and that is, what is the brightness as it appears from Earth? So that's apparent magnitude right there. The second is, when we talk about apparent magnitude, the second important point is the lower numbers indicate a brighter star. For example, the sun is very bright with an apparent magnitude of -25. On the other hand, very faint stars would have a positive number. Now, the faintest star we can see with the naked eye is about a magnitude of +6. So, when we talk about such things as the star Vega, it has a magnitude of about 0. Venus, as you already know, is very bright in the morning, has a magnitude of around -5. Our moon, when it's full, has a magnitude somewhere around -13, right in this area right here. So again, the brightest object is, of course, the sun, and it has a magnitude of just beyond the -25, somewhere around -26 or -27 apparent magnitude. We talk about stellar magnitudes, we can take a look at a couple examples. The Orion constellation, and we can also see that when we take a look at these stars over here, obviously some of them are brighter than others when looked at from the Earth. Now, why are they brighter? Are they bigger or are they closer? That's the question. But over here we can see there's Betelgeuse, there's the star Rigel. Down here we have the 3 belts of Orion, and here's Orion's nebula right below the belt. Now, there's a second type of magnitude called the absolute magnitude. And the absolute magnitude, that is talking about a star, that how bright it would appear if it were from Earth. So if it were 32.6 light years from Earth, how far or how bright would it appear? So in other words, to make it fair, you attempt to line all the stars up at an equal distance, and then you can really get an idea of how bright they really are. So absolute magnitude is just that. It's the absolute brightness if all stars were lined up equally distant from the Earth and all things were equal. Then you could really get an idea of how bright each star is. Again, we take a look at the stars of the constellation Orion, and you already know that these stars in Orion are not anywhere near each other. They're very far from each other, hundreds of light years in distance from each other, as a matter of fact. There's the Orion Nebula. It's also given the donation M42, which is Messier object number 42, named after a famous astronomer, Charles Messier. Our stellar neighborhood is packed full of stars near our sun, all with different brightnesses, all with different magnitudes. So to recap, stars' brightness are recorded using apparent